Hello students, this is Ramarao sir, lecturer in physics. Today I will going to explain the concept of the Bohr's model and hydrogen spectrum. It is also important chapter for JEE mains and advanced. See here, hydrogen spectrum, Bohr's model and hydrogen spectrum. So Bohr's was given some postulates to explain the hydrogen spectrum. Okay, so what he was explained, see here. Suppose consider a nucleus. First postulate was given here. This is a nucleus ZE. Okay, an electron is revolving around the nucleus like this. Okay, an electron is revolving around the nucleus. An electron is revolving around the nucleus like this. This is an electron. An electron is revolving around the nucleus with a velocity v of radius vector r. In this case, the electron is continuously revolving in circular orbit, not elliptical orbit. So why does it is moving in circular orbit means here see, the centrifugal force Fu is equal to mv square upon r, which is balances with the electrostatic attraction force between the ZE and E, that is called the electrostatic force of attraction Fe, which is acting between the nucleus and this electron. Okay, when electron is revolving in a circular orbit, the electrostatic force of interaction Fe must be equal to what is that Fu, centrifugal force. Okay, what is the electrostatic force of interaction? This is equal to K ZE into E upon r square, which is equal to what is that m v square upon r. So this is the first postulate. The electron is revolving around the nucleus in a circular orbit. So when it is revolving in a circular orbit, the centrifugal force which is balances with the electrostatic interaction force between the what is that nucleus and electron. This is the first postulate. And the second one is, what is the second one? See here. When an electron is revolving in a circular orbit, this is a circular orbit, this is a circular orbit, okay. This is a circular orbit, this is a circular orbit, okay. When an electron is revolving in a circular orbit, its angular momentum remains constant. Suppose consider an electron which is revolving in a circular orbit of radius r like this, circular orbit of radius r, ZE and E, which is revolving with an angular velocity omega about this axis of rotation. Okay, so in this case what happening is that its angular momentum remains constant. L is equal to mv r is equal to nh upon 2 pi, where n is equal to what is n, where n is equal to 1, 2, 3 and so on, where h is called as a Planck's constant. Where h is called as, what is the value of h? H is a Planck's constant. Where h is a Planck's constant, h value is a 6.62 into 10 to the power of minus 34 joule second. This is a value of h. This is a value of h, joule second. This is a value of h. Okay, this is the second postulate. When an electron is revolving in a circular orbit, what happening is there, its angular momentum remains constant. This is called as the quantization of angular momentum. That is L is equal to mvr is equal to nh by 2 pi. This is called as the second postulate. Next, third one is, when an electron has to be taken transition from higher energy level to lower energy level like this. Suppose consider this is a higher energy level E2, this is a lower energy level E1. When an electron has to be taken transition from higher energy level to lower energy level like this, it would be emits an energy in the form of a photon, that is equal to this energy, which is equal to difference of two energy levels. Okay, that is, it would be release the energy in the form of a photon, that is delta E is equal to E2 minus E1, that is called, which is equal to h nu, or delta E, this also I am writing delta E is equal to h nu means hc upon lambda, hc upon lambda, h nu is nothing but a c upon lambda. When the electron has to be taken from the higher energy level to lower energy level, it would be emits the energy in the form of a photon. The difference of two energy level would be is equal to, that is E2 minus E1 is equal to h nu, that is equal to Sc upon lambda. Next, in the same case, when an electron has to be taken transition from lower energy level to this E1 and higher energy level E2. When an electron has to be taken transition from lower energy level to higher energy level, then what happening is that in this case it can be absorb the energy. It can be absorb the energy. That means when the electron has to be taken transition from lower energy to higher energy level, it can be absorb the energy, because of you should have to got the kinetic energy to travel to across the metastable energy levels. Okay, what are the metastable energy levels here? See, metastable energy levels means between the ground state energy level and excited energy level. Metastable energy levels. So what are the metastable energy levels? Suppose consider an atom, it has two types of the energy levels. First one is a ground state energy level, it is represented by Eg, and second one is excited energy level, Ex. This is called as the excited energy level. I am representing Ex. Okay, when the electron is went from the ground state energy level to excited energy level here, in the excited energy level, the electron should have to spend with a little amount of time. How much amount of the time? It would be spent is approximately equal to 10 to the power of minus 8 seconds. After 10 to the power of minus 8 seconds, it is falls from the excited energy level to ground energy level. When it is coming from excited energy level to ground state energy level, it will be colliding elastic collisions with the intermediate energy levels. These intermediate energy levels are called as metastable energy levels. Metastable energy levels. These intermediate energy levels are called as metastable energy levels. When the electron has to be comes like this from the excited energy level to in the metastable energy level, here spent with a little amount of time, 10 to the power of minus 13 seconds. So after that it would become like this. Here also spend little amount of time, 10 to the power of minus 13 seconds, and here also it would be spent a small amount of time. What happening is that here also 10 to the power of minus 13 seconds. In each and every metastable state, it would be spent with a little amount of time. That time would be is equal to 10 to the power of minus 13 seconds. So after that, it would be falls into the ground state energy level. In this case, here also some amount of energy releases. Here also some amount of energy releases. Here also some amount of energy releases. In each metastable state, it would be releases some amount of energy. The energy would be appears in the form of a photons. So the total energy, these metastable energy levels we should not be considered. Actually, we should have to consider the metastable energy levels between the ground state energy level and excited energy levels. Okay, is it clear? That would be equal to how much? That would be equal to how much? This is the E excited state, and E is this is the ground state. Okay, when it is going to upward direction, when it is going to upward direction like this, when it is going to upward direction like this, okay, it needs to wants to get some amount of kinetic energy. So that's what the energy would be getting like this in the metastable energy level. Again it will be getting some kinetic energy. K is equal to of mv square. Then after that it will be going to reach here. Here also it will be getting some kinetic energy. K is equal to of mv square. then after going to reach like this. So in the each metastable state, it will be observing some amount of energy. Due to absorption of energy of an electron, it will be it will be taking the transition from ground state energy level to excited energy levels. Okay. So in case of coming to the, in case of taking the transition from excited state to ground state energy level, in each case it will be releasing the some amount of energy. Because of at the excited energy level, the electron has the maximum amount of energy. Okay, these are the Bohr's postulates. He was explained the concept of what is that hydrogen, like a atom and hydrogen spectrum based on this concept. Okay, next see. Next see here. Radius of the nth orbit of an electron. Radius. Radius of nth orbit. Nth orbit. Nth orbit of an electron. An electron in Bohr model. See here, the electron is, when an electron is revolving around the nucleus like this, when an electron is revolving around the nucleus like this, ZE, and this also E. Okay, between these two, nucleus and electron, what kind of the force will be acting? That is called electrostatic force of interaction. Let's say the distance between them is R. And away from this radius, what kind of the force will be acting? That is called to mv square upon R. Is it clear? At the equilibrium condition, these both forces will be equal. That is, what is this force? Fe is equal to electrostatic force of interaction will equal to, what is that? Centrifugal force. That would be is equal to kZe into E upon R square. That is equal to, what is that? mv square upon R. Okay, on both sides you should cancel out R like this. That is k ZE square upon R, which is equal to, what is that? mv square. mv square. Okay, is it clear? Is it clear? mv square. mv square. Is it clear? Next to see, but when the electron is revolving in an orbit, or when electron is revolving in an orbit like this, what would be the remains constant? When electron is revolving in an orbit, what would be the quantized there? Angular momentum is the quantization. What is angular momentum? When electron is revolving in a circular orbit with an angular velocity omega, okay, its angular momentum is remains constant. That is, L is equal to mv, R is equal to nh upon 2 pi is already known. So from this CSC, mvr is equal to nh by 2 pi. This is a angular momentum. So v value, what is the value of it? V is equal to nh upon v is equal to 2 pi into mr. This is with this velocity, it would be revolving around the nucleus. The velocity of an electron in its orbit is v is equal to nh by 2 pi into mr. But already we know what is that in the previous case. The centrifugal force, what is that? The centrifugal force balances with the electrostatic force of interaction. kZe square upon R is equal to mv square. Okay, kZe square, but already know in the previous case kZe square upon R is equal to mv square. Already we have derived. Yes, see, already we have derived kZe square upon R is equal to mv square. Okay, is it clear? kZe square upon R is equal to mv square. I am writing very clearly, see here. But k Z square upon R is equal to v square. Is it clear? Now this v value substitute in this equation. Then what you will get in C? K into z square upon r is equal to m into v square means n square h square by 4 pi square m square into r square. Okay. If the instead of the v plus we have substituted this v value here. Here this v value has to be substituted here. That is n square h square upon 4 pi square m square into r square. You can cancel out r on both sides like this. R gets cancelled out on both sides. Next one also gets cancelled out here. So from this you will get r value. What is the value of r? R is equal to C. R is equal to n square h square upon 4 pi square k z square into m. This is a radius of the nth orbit. This is what I am writing here, Rn. Rn is equal to, what is the value of Rn? See here. What is the value of Rn? What is the value of Rn? See here. What is the value of Rn? The Rn value is what is the value of Rn? See, Rn is equal to Rn is equal to n square h square upon 4 pi square k z e square into m. This is the radius of the nth orbit. So from this what I am writing here, see, Rn is equal to h square upon 4 pi square k e square into n square upon mz. Is it clear? So from this what I am writing, Rn is direct proportional to n square upon mz, where h square by 4 pi square k e square is a constant. But h value also already know. What is the value? What is the value of h? H value also already know. H value also already know. What is the value of h? H is equal to 6.62 into 10 to the power of minus 34. Okay. And k is equal to, what is the k value? K is equal to 1 by 4 pi epsilon naught, this value 8.825 into 10 to the power of minus 12. And mass of an electron, what is the mass of an electron? Me is equal to 9.1 into 10 to the power of minus 34 kilograms. Okay, and z value is 1. Z value is 1. These values are substituted in this equation. Then this you will get Rn is equal to 0.53 into n square upon z. N square upon z in angstroms. So this is a radius of the nth orbit. Okay, I hope that you may be understood this one. The radius of the nth orbit is equal to this much is there. So from this it is very clear that what I am writing, R is direct proportional to n square by z, means for different atoms the radius would be different. That is R1 upon R2 is equal to N1 upon N2 of whole square into Z2 upon Z1. This is a relation between radius and atomic number, and what is that number of the orbits Z1 and Z2. Okay, is it clear? This is a this is a radius of the nth orbit. Radius of the nth orbit is given by Rn is equal to h square upon 4 pi square k e square a square upon mz. Okay, next see, velocity of an electron in nth orbit. What is the velocity? Velocity of electron in the nth orbit. In the nth orbit. In the nth orbit, see. So when electron is revolving around the nucleus, its what is that? Its angular momentum remains constant. Okay, is it clear? That is L is equal to, what is that? L is equal to mvr is equal to nh upon 2 pi is already you know. Okay. So from this V is equal to, what is the V value? V is equal to nh upon 2 pi mr. mr. Let's take this Rn. But Rn value was already knows. What is the value of Rn? See, Rn value was already know. H square by 4 pi square k e square. Rn value is h square upon 4 pi square k e square. Rn value is V is equal to nh upon 4 pi. Rn value is, what is Rn value? See, 2 pi m into h square upon 4 pi square k e square into, what is that? See, h square upon 4 pi square k e square n square upon mz. N square upon mz is already knows. Okay. So this is expands like this where mm gets cancelled out here. See, mm gets cancelled out. V is equal to, what is the V? The V value would be is equal to, what is the value of V here? See, V is equal to n square is there. One n square and one n also gets cancelled out here. ZH into 4 pi square k e square 4 pi square k e square upon hz into 4 pi square k e square upon 2 pi into, what is the remaining term? Remaining term is h square into n. Okay. So one h square will get cancelled out. 2 pi 1s are 2 pi 2s are. Okay. 1 pi is there. So the velocity of the nth orbit is given by, it is representing Vn is equal to 2 pi k e square z. 2 pi k e square z. 2 pi k e square z upon n h. On h is there. 2 pi k e square z upon nh. So from this it is very clear that Vn is direct proportional to Vn. Vn is equal to, what I am writing here? See, Vn value is 2 pi into k value is what is the value of k? K value also already knows. What is the value of k? See here. What is the value of k? See here. Vn is equal to, what I am writing? See here. Vn is equal to 2 pi 2 into 3.14 into 8.85 into 10 to the power of minus 12 into 1.6 into 10 to the power of minus 19 of whole square into z upon n into, what is this value? H value 6.62 take into 10 to the power of minus 34. That is Vn is equal to, what I am writing? See here. C by 137 into z by n. So from this it is very clear that Vn is direct proportional to z by n. So this is a velocity of an electron in the nth orbit. Next, what is the angular velocity of an electron in the nth orbit? See? So the angular velocity of electron is this is in meter per second only. Meter per second. The angular velocity of an electron in the orbit. When an electron is revolving in a circular orbit of radius r, so what is the radius Rn, and which is moving with a velocity Vn, okay, Rn and Vn, and which is revolving with an angular velocity omega like this. With respect to this axis of rotation, the electron is revolving like this. Therefore, angular velocity is given by Vn is equal to Rn into omega n is already known, V is equal to R omega. From this omega n is equal to what is omega n? Omega n is equal to Vn upon Rn. So Vn value also already knows. We have calculated. What is that Vn value? Vn value would be is equal to 2 pi k e square z, 2 pi k e square z upon nh. This is the value of Vn. Next, this is the value of Rn. This is the value of Rn value. So what is the value of Rn? Is divided by Rn value is what is Rn? H square upon or n square h square, n square h square upon 4 pi k e square, 4 pi square into k e square, 4 pi square k e square into m z. This is the value of Rn. Is it clear? Therefore, omega n is given by, what is the value of omega n? See here. Omega n is given by, that is omega n is equal to 4 pi square is there, 4 pi square k e square z into mz, it will become in numerator. That is equal to 8 pi square, 8 pi cube. It will be coming to up, 2 4 is 8 pi cube, 8 pi cube into k square is there, k into k square, e power of 4, and mz square, mz square upon, this is a n cube into h cube, okay. This is what I am ready to see here. Omega n is equal to, now substitute the all values. What are all values? K value is also E value and M value and H value. Then you will getting what is that? 4.156 z square upon n cube. That is omega n is direct proportional to z square upon n cube. This is a value of angular velocity of an electron in the nth orbit of, in its nth orbit. Okay, is it clear? See here once again. Here V is equal to nh by 2 pi into mr. Is it clear? nh by 2 pi into mr. That is called Rn value is the n square upon 4 pi square k square n square upon mz. Okay. Next to see, but L is equal to MVR is equal to nh by 2 pi. So V is equal to nh by 2 pi into mRn. Okay. V is equal to nh upon 2 pi into Rn. Rn value also we have calculated. H square upon 4 pi square k square to n square upon mz. So from this Vn value we have to calculate it. What is this? Vn is equal to 2 pi k e square z upon nh. So its value is c by 137 into z upon n meter per second. Okay. Next, omega value is what is omega? V is equal to R omega is already known. When electron is revolving around in its orbit in a circular path, so its linear velocity would be equal to the product of radius of the orbit and its angular velocity, that is equal to Rn into omega n, that is omega n is equal to Vn by Rn. So Vn value also this much, Rn value also this much we have calculated. That is omega n value is what is that? Omega n is equal to 8 pi cube into k square e power 4 n z square n cube into h cube. 4.156 into 10 to the power of 16. 10 to the power of 16 radian per second. Radian per second. So that is omega n is direct proportional to z square upon n cube. Okay, is it clear? Okay. Now time period. So what is the time period of an electron? See, the time period of an electron is given by omega n value also already know. What is the value of omega n? Omega n is equal to 2 pi Fn. That would be equal to, what is the value? 4.156 into 10 to the power of 16 z square upon n cube. Okay, is it clear? That is equal to 4.156 into 10 to the power of 16 into z square upon n cube. We have calculated that one. See, z square upon n cube into 10 to the power of 16. Okay. So from this is what I am writing. See here, frequency will, what is the frequency? Fn is equal to 4.156 upon 2 pi into 10 to the power of 16 into z square upon n cube. So from this it is very clear that the frequency Fn is direct proportional to z square upon n cube. Okay. Next, the period of rotation of the time period is given by, what is the period of rotation? T is equal to 1 upon Fn. That is called 1 upon Fn means it would be, becomes a reciprocal, that is 2 pi upon 4.156 into 10 to the power of minus 16 into n cube upon z square. Okay. This is T is equal to 1.5 into 10 to the power of minus 16 into n cube upon z square. So from this the time period would be direct proportional to n cube upon z square. So this is a relation between time period and nth orbit and what is that? Atomic number of the hydrogen atom. Okay, is it clear? This is a frequency and this is a time period, and what is this? Is a angular velocity. Okay, this is a angular velocity, and this is a radius. This is a velocity, and this is the radius of the nth orbit. So these are nothing but different parameters are applicable when an electron is revolves around the nucleus. Next, see, so energy of an electron. Okay. Energy of an electron when it is revolving in an nth orbit. Suppose consider an electron which is revolving like this in the nth orbit around the nucleus. It's a nucleus. So when it is revolving around the nucleus, between this electron and nucleus, electrostatic potential energy has to be presented. Next, when it has in motion with the velocity of Vn, it possesses some kinetic energy also. So what is the kinetic energy of electron? Kinetic energy of electron is given by, let's take the mass of an electron is m. So the kinetic energy of an electron is given by, what is that? K is equal to half m into Vn square. Okay, but Vn value also already know. What is the Vn value? 2 pi k e square z upon nh. 2 pi k e square z. 2 pi k e square z upon nh. That is half m into 2 pi k e square z upon nh. This is the velocity of an electron. Once again see, 2 pi k e square z upon nh. 2 pi k e square z upon nh of whole square. Okay, this is the kinetic energy. It would be equal to kn is equal to of m into below 4 pi square k square e power of 4 into z square upon n square into h square. ठीक है. So 2 1s are 2 2s gets cancelled out. That is kn would be is equal to, what is the value of kn? 2 pi square k square e power of 4 z square m upon n square into h square. This is our kinetic energy of an electron in nth orbit. See here, this is the value of n, 2 pi k e square z upon h we have substituted. That would be 4 pi square k square e power of 4 into z square n square into h square. That is 2 1s are 2 gets cancelled out here. That is kn is equal to 2 pi square k square e power of 4 z square m upon n square into h square. So this is what is this? This is the kinetic energy of an electron in the nth orbit. Next, potential energy. When the electron is revolving at certain distance, when it at certain distance around nucleus or this point or this point or this point, wherever it. So between the discharge and discharge, electron and nuclear charge, what happening is that electrostatic potential energy has to be positive. So what about the radius of this electron which is revolving? Let's say this is the nth orbit. So the electrostatic potential energy between the electron and this nucleus is given by U is equal to minus k into Ze into E upon Rn is already known. Okay. The electrostatic potential energy, what is that? U is equal to k into Q1 Q2 upon Rn. R value is already known. That is minus k into Ze into E upon Rs. That is equal to, what I am writing, U is equal to minus k Ze square upon R L Q1 Q2 upon Rn only. But already know what is the value of radius. The value of radius is equal to h square upon 4 pi square k e square. H square upon 4 pi square k e square. That is equal to minus k Z square. This value is minus k Z square. So Rn value is h square upon 4 pi square k e square. That is equal to minus k Z square. Here also writing hand, see. Here right. U is equal to minus k Z square upon h square upon 4 pi square k e square into h square upon 4 pi square k e square into n square by mz into n square by mz. This is the value of R. Okay, is it clear? That is U is equal to, what is the value of C? Minus this term will be going to the numerator. K 4 pi square in the numerator will get in 4 pi square k square k square. Next e power of 4 z square, it will be going to z square into m upon n square into h square. So this is the potential energy of an electron in the nth orbit. The potential energy of an electron in the nth orbit is given by minus 4 pi square k square 4 pi square, it will be going to, this total term is going to minus 4 pi square k into k square e square into e power of 4 into z square z into z square into a. Okay, is it clear? This is the potential energy of an electron in the nth orbit. That is equal to, here see kinetic energy is equal to 2 pi square k square e power of 4 z square into n square into h square. the potential energy would be equal to, this is what I am writing, see here, U is equal to minus 2 into, this is a 2 pi square, 2 into 2 pi square, what I am writing, see here, 2 into this total value you will getting, that is equal to 2k. Un is equal to what is that? Let's say this is Un. Un is equal to what is Un? Un is equal to 2kn. Is it clear? Next, the total energy. So what is the total energy? Total energy of electron is given by T. The total energy of electron in nth orbit is given by Te is equal to K plus Kn plus Un. Okay, Kn means Kn, that is called Kn, plus Un means minus 2k into n, that is Te is equal to what is the Te? Minus 2k into n. This is the total energy of an electron in its nth orbit. Is it clear? I hope that you may be following and you have aware about this energy of the electron in its orbit. Therefore, what is the T is equal to minus 2kn, Un is equal to minus 2kn, and kn is equal to what is that? 2 pi square k square e power of 4 into z square m upon n square into h square. So what is the relation between them? See here, total energy, potential energy, kinetic energy will be getting what is that? This is T minus 2kn, this is Un also minus 2kn, and k is nothing but k, this is equal to k. Let's say this is equal to k. You will get it, what is it? 1 is to minus 1 is to minus 1 is to this 2. Okay, that is the total ratios of the energies of the electron in an nth orbit. Okay, is it clear? Is it clear? No doubt, sir. This is what I am writing, see here. The total energy is equal to minus 2k means, this is what I am writing, see here. The total energy of the electron can be written as Te is equal to, or delta E is equal to, this is I am taking delta E, or E is equal to minus 2 into Kn. What is the Kn value? This Kn value is equal to, what I am writing, this total value is minus 13.6. Kn value is, what is the Kn value? Kn value is 2 pi square into k square into e power of 4 into z square m upon n square into h square. This is the En. En is equal to minus 13.6 electron volts into z square upon n square. Z square upon n square into electron volts in the form of an electron volt is equal to minus 13.6 into z square upon n square in electron volts. Okay. So what is the frequency? How much amount of the frequency has to be emitted? So when electron has to be taken from the higher energy level to lower energy level, how much amount of the frequency it would be released? See here. Okay. Next, when an electron takes or when electron falls from higher energy level to lower energy level, that means nth orbit to here, higher energy level to, let's take this is a ground state energy level, this is a excited energy level. Is it clear? When electron has to be taken from higher energy level to lower energy level, which is releasing energy En is equal to what is that? Minus 13.6 into z square upon n square in electron volts. Let's take this is a ground state energy level, you can represent N1, and excited energy level we should represent, this is N2. This is what I am writing, see, delta En is equal to, or En is equal to minus 13.6 into Z square into 1 by N2 square minus 1 by N1 square, the difference of energy levels. Okay, this is what I am writing. See here, En is equal to minus, this is I am writing in alternate, reverse, in a reverse order I am writing. That would be is equal to 13.6 into Z square into 1 by N1 square minus 1 by N2 square. This is the energy of the n orbit. Okay. When we have considered the hydrogen spectrum, or when we have considered the hydrogen spectrum would be like this. How would be the hydrogen spectrum is forming here? See, when the electron has to be taken transition from the higher energy level to lower energy level, what happening is that it would be release the energy with a certain frequency nu. Okay, this is energy I am writing in the form of frequency. E is equal to h nu, that is equal to h nu, that is equal to minus 13.6 into Z square into 1 by N1 square minus 1 by N2 square. Okay, that is called hc by lambda, that is equal to 13.6 into Z square into 1 by N1 square minus 1 by N2 square, or nu bar is equal to 1 by lambda is equal to, this is take this side, and what you will be getting rz square into 1 by N1 square minus 1 by N2 square. So where r is called as a Rydberg constant, its value is r is equal to 1.1 into 10 to the power 7 meter universe. Okay, so based on this concept, we have explained what is that the hydrogen spectrum. What is on a hydrogen spectrum? See here, how would the hydrogen spectrum is formed? When suppose consider a hydrogen spectrum here, this is a hydrogen spectrum, H2 like a spectrum where N1 is equal to 1, this is 2, 3, 4, 5 and 6. While going to upward direction, what happening is that the energy density has to be increased. Energy levels, energy densities. Just wait. These are the energy levels. Okay. These are the energy levels. N1 is equal to 1, 2, this is a 2, second, third, fourth, fifth, sixth, and so on. Okay. When the electron has to be taken transition from N2 to 1 to N1 is equal to 1 like this. Here, what kind of series has formed? Lyman series is forming, which is forming in the UV region, ultraviolet region. Lyman series is forming. When the electron has to be taken transition from N2 to 2, 3, 4 up to and so on, infinity, and N1 is equal to 1, then Lyman series is forming. This Lyman series would be in the UV region. Next, when the electron has to be taken transition from third, N2 is equal to 3 to N1 is equal to 1 like this. Then what kind of series are from? Balmer series. Balmer series is forming. This is in visible region. When electron has to be taken transition from N2 is equal to 3 to N1 is equal to 2, like this. So Balmer series is forming. This is a Balmer series which is forming in the visible region. Next, when the electron has to be taken transition from N2 is equal to 4 to N1 is equal to 3, like this. Okay, N1 is equal to 3. So here passion series is forming. Paschen series is forming, which is in the IR, infrared region, IR region, which is forming in the IR region. For Paschen series, see here, for Paschen series is equal to N2 is equal to 2, 4, 5 up to infinity. These are the infinity lines. To N1 is equal to 3. Next, when the electron has to be taken transition from N2 is equal to 4 to N1 is equal to N2 is equal to 5 to N1 is equal to 4 like this. So in this case, bracket series is forming, which is a near IR region, which is forming near IR region. Next, see, when the electron has to be taken transition from N2 is equal to 6 to N1 is equal to, what is that? N1 is equal to 5 like this, and so on. Next, fund series is formed. What is this is called as a fund? P fund series. P fund series forming. This is which is forming in the for IR region. For IR region. Okay. So the respective wavelength or the respective wave numbers for this. The respective wave numbers of this series are the spectral lines. The respective wavelengths of the spectral lines we can determine by using nu bar is equal to, what is a nu bar? Nu bar is equal to 1 by lambda is equal to r z square into 1 by n1 square minus 1 by n2 square. Okay, this is the standard formula. So in this case, when electron has to be taken transition from N1 is equal to 1 to N1 is equal to, let's take the ground state energy level is N1 and excited energy level is N2. When the electron has to be taken transition from N2 to N1, the number of spectral lines formed in this. These are the K alpha, K beta, K gamma, L alpha, L beta, L gamma, M alpha, L beta, M gamma, like this. How many number of spectral lines are formed here? The number of spectral lines are formed in this case given by N of E is equal to N2 minus N1 plus 1 into N2 minus N1 upon 2. So this many number of spectral lines are formed when the electron has to be taken transition from N2 to N1. Suppose if N1 is equal to 1 and N2 is equal to M10, then the number of spectral lines would be N of E is equal to, what is that? N of E is equal to N minus 1 plus 1 into N minus 1 upon 2. So plus 1 minus 1 will be gets cancelled out. So the number of spectral lines would be is equal to how many? N into N minus 1 upon 2. So these are the very important in the J maths purpose. J maths purpose, this is a very important formula. Okay. This is also very important to solve J maths problems. See here. Okay. I hope that you may be understood. The number of spectral lines are formed here like this, N of E. And if it has to be taken transition from N1 is equal to 1 to N2 is equal to N, that is N of E is equal to N into N minus 1 by 2. Okay. Is it clear? See some problems based on this concept. Suppose consider two energy levels. These are the two energy levels. These are the two energy levels where N2 is equal to 3 was given, N1 is equal to 1. Okay. An electron has to be taken transition from third energy level to first energy level, and it is releasing the energy. E is equal to, or delta E. Delta E is equal to 108.8 electron volts. Let's take this atom is nothing but a hydrogen like atom, that is equal to this atom is nothing but not hydrogen, this is another atom, not hydrogen atom, out of other kind of the atom. So the electron has to be taken transition from N2 is equal to 3 to N1 is equal to 1. In that case, the energy difference between the this levels was given 108.n electron volts. Then find the atomic number of that atom. So what is atomic number? Z value is how much? That is we should have to calculate now. Okay. So then we can use what is that? Delta E is equal to already know. Delta E is equal to what is that? 13.6 Z square into 1 by N1 square minus 1 by N2 square is already knows. Okay, in electron volts only. This is also in the form of electron volts. This value was given 108.8 is equal to 13.6 into what is this value? This should be is equal to 13.6 into Z square 1 minus 1 by what is the N2 is equal to 3. 3 means 9. Okay, that is what I am writing here. See, 108.8 is equal to 13.6 Z square into 8 by 9. Is it clear? So Z square, what is the Z value? Z square would be is equal to 108.8 into 9 upon 13.6 into 8. This is the 108.8 value. This is also 108.8. Okay. From this Z is equal to how much? Z is equal to root 9. That would be equal to Z is equal to 8. This is the atomic number of the atom would be equal to Z is equal to 3. Okay. So this question was asked JE 2025. And next question is very simple question. Very simple question was asked in 2025. Okay. What was given? See, an electron has to be taken transition from second excited state to first state. Second excited state. Second excited state means 1, 2, 3, 4, 5 like this. This is a first excited state. Second excited state means n is equal to 3. An electron has to be taken transition from second excited state to ground state. Then find the number of spectral lines are formed in that case. This is second excited state. This is a second excited state to first state. That means ground state. This is let's say ground. This is a ground state. Then find the number of spectral lines. How many number of spectral lines are formed in this case? Okay. So what formula we can use in this case? See, the number of spectral lines would be forming in this case. N of E is what is already known. N2 minus N1 plus 1 into below N2 minus N1 upon 2 is already known. Is it clear? Is it clear or not? So N2 is equal to how much? N2 is equal to second excited means N2 is equal to 3. N2 is equal to 3. First excited state N is equal to 2. Second excited state N is equal to 3. Third excited state N is equal to 4. Nth excited state N plus 1. Okay? So you should have to count like that. That would be N of E is equal to N of E. N2 minus N1 means 3 minus 1. Okay? Second excited means 3 minus 1 plus 1 upon 2 into 3 minus 1. So plus minus will be gets cancelled out. N of E would be equal to what is N of E? N of E is equal to 3 by 2 into 2. That is equal to 3 spectral lines are forming. Okay? Is it clear? I hope that you may be understood about the number of spectral lines are formed. Do you have any doubt? Please call the scrolling number in this concept. Okay?